first property is minus integral of minus infinity to plus infinity x of t del of t dt equal to x of 0. That is the first property. What is the mathematical expression for impulse function? Minus infinity to plus infinity del of dt equal to 1. Del of t dt equal to 1 and del of t equal to 0 when t is not equal to 0. So this function will exist only at t equal to 0. In other words, the index equal to 0, then only this will exist. That's why the delayed impulse function t minus a will exist when t equal to a. Then only this index becomes 0. So del of t will exist when t equal to 0. First, let us consider this alone. Here, x of t, del of t, if you consider this, let us assume that x of t is exist at t equal to 0. That is important. It is continuous at t equal to 0. Continuous means its value exists at t equal to 0. That is the meaning. So x of t is continuous at t equal to 0. Therefore, its value exists at t equal to 0. But this function will exist only at t equal to 0. Therefore, we can say that otherwise it is 0. Del of t is 0 otherwise. Therefore, instead of writing x of t del of t, we can write x of 0 del of t, we can write. Therefore, the integration becomes, first integration becomes minus infinity to plus infinity. X of t del of t dt equal to, if you substitute this one, why we convert the x of t equal to x of 0? Because del of t exists only at t equal to 0. These two are in product. That's why the x of 0 alone can multiply with the del of t. Therefore, this can be written as minus infinity to plus infinity. X of 0 del of t dt. That is equal to x of 0 is constant. The value of x at a particular value, particular time means it is a constant. That's why we can take that outside is a constant. Suppose I'm having a signal like this. At t equal to 0, what is the value of x? That is called at this point, the value of x equal to x of 0. So it is a constant. That value is constant. That's why we can write this integration can be written as x naught multiplied by minus infinity to plus infinity del of t dt. But this is equal to 1. Therefore, it is equal to x naught. Therefore, this is the first property of the impulse function. Second property, x of t multiplied by del of t minus t naught equal to x of t naught multiplied by del of t minus t naught. So what is this? This is a delayed impulse function. It will exist like this. This is an impulse function. Impulse function will draw like this. This t, I of t, impulse function. At t equal to t naught, this will exist. It is a delayed impulse function. So this will exist only at t equal to t naught. Here, these two are in product. That's why the x of t is like this. X of t is like this. It exists from minus infinity to plus infinity. But del of t minus t naught exists only at t equal to t naught. If you multiply these two, all other times impulse function is 0. That's why the value of x at t equal to t naught only will be multiplied with the impulse function. And let us assume that x of t is continuous at x of t is exist are continuous at exist at t equal to t naught. Therefore, we can say that uh, we can say that x of t equal to x of t naught at t equal to t naught. Therefore, we can say that x of t del of t minus t naught equal to x of t naught. All other points, its value exists, but impulse function is not exist. That's why we can say that instead of writing x of t, we can simply write x of t naught, a constant, or the value of x at t naught multiplied by del of t minus t. That is the second property. Now let us see the third property. Third property is what? Integral of minus infinity to plus infinity x of t del of t minus t naught dt equal to x of t naught. X of t naught. To prove this, already we know what is the second property. X of t del of t minus t naught equal to x of t naught multiplied by del of t minus t naught. So we can say that uh, this integration can be written as by using this second property. This integration can be written as minus infinity to plus infinity x of t naught del of t minus t naught dt. That is also equal to x of t naught multiplied by minus infinity to plus infinity del of t minus t naught dt. Let us assume that t minus t naught equal to lambda. So what is dt? dt minus, this is constant. That's why it becomes 0. If you differentiate on both sides, it becomes a d lambda. So this can be written as, now the integration becomes x of t naught. What happens to limit as t tends to minus infinity? Minus infinity minus t naught is minus infinity. That's why the lower limit is minus infinity. Upper limit, when t tends to infinity, lambda also tends to infinity because infinity minus t naught is infinity. Therefore, x of t naught minus infinity to plus infinity del of lambda into d lambda. We know that it's a property of impulse signal equal to 1. Therefore, this is equal to x of t naught is the answer. Therefore, if you multiply by a delayed function of t naught, then its integration is equal to x of t naught. That is the third property. Now, let us see the fourth property. Fourth property, what is the fourth property? Del of at equal to 1 by modulus of a multiplied by del of t. This is the fourth property. To prove this, now let us consider. Consider a function. Third property, minus infinity to plus infinity x of t multiplied by del of at dt equal to what? Let us assume that a is greater than 0. Case 1. Let us assume that a is greater than 1. It is positive. And let us assume that at equal to lambda. Therefore, t equal to lambda by a. Let it be 1. If you differentiate on both sides, dt equal to d lambda divided by a, since a is constant. If you substitute all this here, what you will get? Integral of minus infinity to plus infinity. X of t becomes x of lambda by a multiplied by del of del of lambda dt equal to d lambda divided by a. This a is constant. If we take this a out, what you will get is, integral of 1 by a is taken outside, minus infinity to plus infinity, x of lambda by a is constant, lambda by a, del of lambda d lambda. This function will exist only when lambda equal to 0. Therefore, by using that third property, we can, first property, we can write, what is first property? The first property is the first property. First property say that minus infinity to plus infinity, x of t, del of t dt equal to x of 0, because del of t exists only at t equal to 0. Therefore, here we can say that this will exist only at lambda equal to 0. Therefore, we can say that x of 0 divided by a, both are constant. That's why we are taken outside. That's why minus infinity to plus infinity, x of 0 is taken outside, del of lambda d lambda. This is equal to 1. This is property of impulse function. This is equal to 1. Therefore, this is equal to x of 0 divided by a. Now, let us consider the case 2. Case 2 is when a is less than 0. So consider the same function, minus infinity to plus infinity, x of t del of at dt equal to what? That is, a is less than 0. That's why one minus will be here. So again, consider at equal to lambda. Therefore, t equal to lambda by a. That is 1. Therefore, dt equal to d lambda divided by a. That is 2. If you substitute all this here, what you will get is minus infinity to plus infinity, x of t equal to lambda by a, del of minus lambda dt equal to what? D lambda divided by a. If you take that 1 by a outside, 1 by a outside, what you will get? Minus infinity to plus infinity, x of lambda by a. And this is this will exist only when lambda equal to 0. Therefore, there is no meaning of that minus sign. This will exist only when lambda equal to 0. That's why it is an even function. Therefore, del of lambda equal to del of minus lambda is an even function. Therefore, we can write del of lambda d lambda. By using the first property, this will exist only when lambda equal to 0. That's why this becomes x of 0, because it will exist only when lambda equal to 0. Therefore, x of 0 divided by a integral of minus infinity to plus infinity, del of lambda d lambda. This is property of impulse function. This is equal to 1. Therefore, that is equal to x of 0 divided by a. Whether a is positive or negative, we got the x of 0 divided by a. That's why we got positive value only. Therefore, we can conclude that integral of minus infinity to plus infinity, x of t del of at and dt equal to 1 by modulus of a. Because why? A is positive or negative, we got positive 1 into x of 0. This is the result we got for both positive and negative. We got the same result. So, what is the result we got? Minus infinity to plus infinity, x of t del of at dt equal to 1 by, always positive we got, therefore modulus of a multiplied by x of 0. Let it be a. We know that from the first property, we know that minus infinity to plus infinity, x of t del of t dt equal to x of 0. That is first property. Let it be p. First property. So here we can substitute this first property here. If you substitute this first property by using A and B, right? A, we can say that this we can substitute instead of x naught, we can substitute this. Then what we will get? Minus infinity to plus infinity. X of t del of at dt equal to 1 by modulus of a integral of minus infinity to plus infinity. Instead of x naught, I am substituting the first property. X of t del of t dt. So if we bring this constant inside, then it becomes integral of minus infinity to plus infinity. X of t 1 by modulus of a del of t dt. Now, if we compare left hand side and right hand side, what is the left hand side in the integration? X of t, here also x of t, dt, dt, dt. What is the remaining thing? Del of at equal to del of at, the left hand side, equal to right hand side 1 by modulus of a del of t. This is property 4. That's all. Hence proved. What is property 4? Del of at equal to del of at equal to 1 by modulus of a multiplied by del of t. Hence proved. Now let us see the fifth property. Integral of minus infinity to plus infinity. X of tau del of t minus tau d tau equal to x of t. This is called convolution integral. We will see about this in detail later. Now let us prove this first. To prove this, consider the third property. To prove this, let us consider the third property, minus infinity to plus infinity. X of t del of t minus t naught dt equal to x of t naught. Replace t by tau and t naught by t. In the third property, this is the third property. Replace this like this. So what we will get? Minus infinity to plus infinity. X of t is replaced by tau. And del of t is replaced by tau minus t naught. T naught is replaced by t. D tau equal to x of t. So if you compare with the fifth property, x of tau we got, d tau we got, x of t we got, except this. Here del of t minus tau, here del of tau minus t. We know that it is an even function, that's why del of tau minus t also equal to del of t minus tau. That's why if you replace this by using that even property, you will get x of tau del of t minus tau d tau equal to x of t. So we got the fifth property. That's that. This is called convolution integral. There's a lot of applications. We'll see later.